All right, linear equations. Um, what you're dealing with right now is a first order linear equation. How do you know it's a first order linear equation? Well, it's linear for one thing. What does linear mean? Uh, it means I say it's something of this form. Oh, no, way up there. All right, so something like this. This is a linear equation. Okay. Oh, this is a y prime, not a double prime. And there can be functions in front. The idea here is, I mean, this is linear. Okay, f of x can be anything. It doesn't matter if f of x is linear or not. Y has to be linear. It's linear in y. Because it's not squared or there's no sine y or anything. It's just y prime plus y. It's linear. Like that, like this is a line in algebra. This is a linear form of a differential equation. And what you're doing is you're saying, okay, I've got this function in front. Let's just call it p of x, y plus q of x. Let's just say this. Uh, y is equal to f of x. Now, to put it in standard form, you divide through by p of x. In other words, you don't want a coefficient in front of y prime. So, so it looks like this. Okay, so this is how you put it in standard form. Now, what you're doing here, the idea and the goal, is to set this up so it's the product rule. Okay, if you remember the product rule from calculus, the derivative of let's just call it xy is uh, y prime dx plus uh, x dy, right? Okay. So you can set this. You're going to use this integrating factor so that you can put it in this form. The integrating factor is like one of those magic tricks of calculus. Okay, the integrating factor, and there's a proof behind it, but I'm not going to do it. But the integrating factor, which is going to be, we're going to call this y prime plus p of x, y is equal to f of x. We'll just call it the standard form here. The integrating factor, u, is equal to e to the integral of that function, this function, dx. And when you multiply everything by this, it magically turns this formula into the product rule, like this. And then you integrate both sides, and you have xy, and you can solve for y. Okay, so that's what we're going to attempt to do with the problem that you have. So let's look at the problem that you have. So yours is dy dx is equal to x squared e to the negative xy, wow, minus 2y. Okay. Oh, no, it's not xy. It's 2x. I'm sorry. I'm losing my mind. Okay, good. That's a whole lot easier. 2x. E to the negative 2x. Okay. All right, so let's put this in standard form. That means put all the y's on one side and leave the f of, this is f of x. Notice it's not linear. It's okay. F of x doesn't have to be linear. So we're going to have y prime plus 2y is equal to, make sure I'm on the screen here. Yeah, I wasn't, but I am now. Y prime plus 2y is equal to x squared e to the negative 2x. Okay, so we're going to use this integrating factor. P of x is 2, so it's going to be e to the integral of 2 dx, and that is going to be e to the 2x. right? Oh, and look how that's going to magically cancel this out and make this side look pretty. See how that's going to work? Okay, so we multiply everything by e to the 2x, okay? So this will be e to the 2x y prime plus 2e to the 2x y is equal to x squared, because 2x minus 2x is 0. When you multiply those two together, you add the exponents and the e goes away. Magically. Isn't that just magic? Okay, now, but notice that if you take the derivative of this, you get this. That's where the product rule comes into play. Okay? So remember the product rule, and I'm going to write it over here, of xy is the first times the derivative of the second plus the second times the derivative of the first. Okay? And that's a y. Okay? First times the derivative of the second plus the second times the derivative of the first. So the first here is y, and the second is e to the 2x. So what this is, and you can check this on your own to believe yourself, it is the derivative of e to the 2x y. Okay? I didn't do anything to this yet. I haven't changed it. These are the same. Okay? And that is equal to x squared. Okay. So now, you just integrate both sides. If I can find... Now we'll integrate both sides. The integral of a derivative is what's inside. So this is e to the 2x y, and the integral times the integral of x squared dx. Okay. So y e to the 2x is equal to 1/3 x cubed plus a constant. And now you have to solve for y by dividing through on both sides, and you get y is equal to 1/3 x e to the negative 2x plus c e to the negative 2x. Okay, so there's your solution. Now it's an initial value problem. Let's see what it is. It's y of 0.1 equals 10. Okay, so now you got to solve for c. So 10, y is 10. Let me move this up. Okay, so 10 is equal to 1/3 x times e to the negative 0.2, right? Plus c e to the negative 0.2. Because 0.1 times 2 is 0.2. Okay. And then, shoot, what now? What is e to the negative 0.2? I don't know how they want you to put this answer in. Oh, there's an x right here. I forgot. It's actually an x cubed. So we have to put that 0.1 cubed in there. Okay. This is cubed. Okay, so 0.1 cubed is 0.001 divided by 3 times e to the negative 0.2. You have to get a calculator and figure all that out and solve for c. That's the easy part. That's algebra. But that's pretty much it.